friends, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today in this session, we will go to the next topic or the module, green chemistry and fuels. So we will understand the concept of green chemistry in this session, and this is the course outcome 5. So here are the topics. Let us understand what is green chemistry, then what are the benefits of green chemistry, then why do we really require this green chemistry in our practical applications. Then there are 12 principles of green chemistry. Of that, we will see these three in detail: prevention of waste or byproducts, then atom economy, then less hazardous chemical synthesis with some examples. So these are the topics we are going to cover today. So moving to green chemistry, what is green chemistry? It is described as sustainable chemistry, that is, there is chemistry that is helping in sustainability, then chemistry that is being by design. So we are wearing the design so that it is making the product or the process less harmful. Then pollution prevention at the molecular level. Thus, it will also help us in preventing the pollution. So, this concept of green chemistry is very important in our daily life. So, this actually focuses on the processes and products that reduces or eliminates the use of polluting substances. So, using the polluting substances or the byproduct that is coming out during the process has to be reduced or eliminated so that it prevents pollution. And any synthesis, whether performed in teaching, laboratories or industries, should create none or minimum byproducts. So, any process that we make or do during our learning laboratories or industries should produce or should not produce byproducts. So, it should be minimum or should not produce at all. So, that pollute the atmosphere. So those will be polluting the atmosphere. So we have to minimize the byproducts or the waste that is generating from these processes. So what are the benefits of green chemistry? It is more economical. So it is cost effective. Then energy efficient. Less energy or the energy input will be less. Lowers the cost of production and regulation. So it will be lowering the cost of production through these processes or the green chemistry process. Less waste generation, so the waste generated will be reduced. Then fewer accidents. We have seen a lot of accidents happening in the industries due to these hazardous substances or gases or fuels. So it is the green chemistry which will prevent these accidents. So the safer products, the products obtained from these processes will be safer in usage. Then it will ultimately give healthier workplaces and communities. So even the workplace for any labor will be healthier and the communities where we are using the product will be better. Then it protects the human health and the environment. So using of these safer products will protect us from bad concerns and also will have healthy environment and therefore will give better result. So the same is depicted in the figure here. It gives clean products, eco-friendly process, then less labor is required if it is like using less hazardous substances. Then non-toxic byproducts or the waste will be generated. Then simple procedures and safe to use. The products should be non-toxic or the byproducts at least obtaining from these processes should be minimized. So why do we really require this green chemistry? We have seen the benefits. So we know that chemistry is undeniable. So it is undeniable that we cannot deny the chemistry in our daily life because it is present in every aspect of our daily life. So chemical developments bring new environmental problems. So whenever we are producing a product, it is giving some problem to the environment and harmful unexpected side effects. So we are taking in some tablets or some pharma products, it means it also has some side effects. For example, even the fertilizers that are being used for the crops will have side effects on the food grain. So that is how it really works. So it is better that green chemistry will help us in reducing these, so which will result in the need of greener chemical products. So the products should be greener, which is nothing but eco-friendly products. So it is always better to prefer eco-friendly products, so that the effect on the environment is also lower. Example is DDT that we spray for the crops. Then green chemistry looks at pollution prevention at the molecular level, that is like modeling the molecules or during the product manufacturing will reduce the pollution, so that it will help the environment sustainability. So it is extremely important area of chemistry due to its importance of chemistry in our world today and the implication it can show on our environment. So ultimately it will reduce the environmental pollution, so that we will be healthier, so therefore increases the sustainability. So the green chemistry supports the invention of more environmental friendly processes, more environmentally friendly chemical processes that reduce or even eliminate the generation of hazardous substances. What is hazardous? Harmful to both humans and environment. Even the environment gets polluted, it is again humans that we inhale the air, gas, water, whatever we are taking in will be from the environment. So it is our duty to protect the environment from any pollution. So now coming to the principles. What are the principles of green chemistry? There are 12 principles. So first one is the prevention. It is always said that prevention is better than creating any waste. So prevention is always better, like prevent the waste than treat or clean up the waste after it is formed. So after forming, the cleanup will have we need to invest a lot of money in cleaning up or treating that waste. So it is always better to prevent the waste generation. So that is a concept. Then atom economy. So what is this atom economy? Synthetic methods. So we are having a method. Now we have method 1 for a product, for a manufacturing a product. So this method should use 100% of its reactants. So that is nothing but atoms at the molecular level. It is utilizing the complete reactants that are being used as raw materials. So that is nothing but atom economy. So the synthetic method should be designed to maximize the incorporation of all the materials used in the process into a final product. So that is the atom economy. Prevent waste, atom economy. Then what is the next one? Less hazardous chemical synthesis. So the chemical synthesis process, whatever we are using, so should produce or generate or should less hazardous chemicals. So even the usage of the raw materials should be less hazardous in nature or harmful in nature. So that is what it depicts. So whenever practicably applicable, so synthetic methodologies should be designed to use and generate substances that possess little or no toxicity to human health and environment. So it means that we should use the methods so that the raw materials or the generating waste that is coming out from the process should be very less in hazardous substances should be less in quantity. That is nothing but less hazardous synthesis, or the chemicals involved in the synthesis should be less hazardous. That is how It is giving an idea how it possesses little or no toxicity. It should not be toxic to human health and environment ultimately. So this is how there are three different principles that is explaining. So prevent waste, atom economy, less hazardous synthesis. So these are the different 12 principles: benign chemicals, benign solvents, energy efficient, renewable feedstocks, then reduced derivatives, catalysis designed for degradation. So this is also very important. Like after we produce some byproducts, the degradation is also important. Real-time analysis and accident prevention. So these are the different principles that are involved in green chemistry. So in this session, we will cover these three in detail. The first three, we will have a glance on how the 12 are being used in the green chemistry. So designing safer chemicals. So we have to use safe chemicals for any process that is taking place to obtain a final product. So chemical products should be designed to preserve efficacy of the function while reducing toxicity. So the efficacy should be better while simultaneously it should reduce the toxicity to the human health and environment. The safer solvents and auxiliaries. So the use of auxiliary substances, which are nothing but solvents, separation agents, should be made unnecessary whenever possible. So we have to reduce the use of these auxiliary substances so that it will reduce the pollution. But even when it is used, it should be harmful. Even if it is used, it should be harmful. So designed for energy efficiency. So the input of fuel or the energy should be lower. That is, energy requirement should be recognized for their environmental and economic impacts and should be minimized. It means this energy input also gives the increase the product cost. So it is important to think in both the ways, like environmental issues and economic impacts, so that the energy efficient products can be obtained. So therefore the energy input should be reduced during manufacturing. So synthetic methods should be conducted at ambient temperature and pressure. So ambient temperature is nothing but the temperature whatever present in that manufacturing process. So room temperature is equivalent to room temperature. So it should be we have to prefer methods wherein the process takes place at ambient temperature and pressure, so that we need not apply more pressures or temperatures. That will reduce the efficiency energy input. Use of renewable feedstock. So we are using some raw material. So we have some raw material that to be used during product synthesis. So these whatever the raw material we are using should be renewable. That is available in more in the environment, or so that they will not face the problem of depleting or lessening in their number whenever the product is increasing. The product demand is increasing. We keep on using the raw material so that it gets depleted. So when we are using renewable sources, it will not be depleted. So that is how it works. So it is always we prefer for the renewable feedstocks. So the depleting problem will be solved. Then comes the reduced derivatives. So reduced derivatives is nothing but we will be using some agents for converting the chemical methods or the chemical reactants into some other groups, manipulating the groups so that they undergo into the reaction. So that is nothing but derivatization. So whenever we are doing derivatization, that will favor some reaction. So unnecessary derivatization should be avoided. So it means blocking some groups in the molecular level, or protection, deprotection, temporary modification of physical chemical processes that we do for that particular reactants should be avoided whenever necessary, so that we reduce the time in manufacturing, or also the efficiency, like our process time will be reduced and the cost of the process also reduces. Then catalysis. Catalytic reagents. These catalytic reagents are used to speed up the reaction or for the reaction to take place. So, as selective as possible are superior to stoichiometric reagents. So we have to selectively take in consider the catalytic reagents so that we get good stoichiometry in the final product. Design for degradation. So degradation is also important. Once there is a production of waste or a byproduct, degradation is the main concept that we have to take care. Chemical products should be designed so that at the end of their function, they do not persist in the environment. It means they should not be present in the environment so that it will be harmless to the environment. So the product should be in such a way that it gets degraded very easily. So instead, they break down immediately into innocuous degradation products. Innocuous is harmless degradation products. So it has to break down to its simple molecules so that it will degrade easily. Then comes the real-time analysis for pollution prevention. So we are intended to keep on analyzing the product during its manufacturing. So it is also important to monitor on the byproducts and the waste. So any analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. So it is important to monitor, check and control its byproducts that are harmful so that we can avoid this formation of hazardous substances. Next, the last one or the 12th principle is the inherently safer chemistry for accident prevention. So this is very important. Like we are producing some products with some different methods. So that methods can sometimes give explosions, creating accident. So substances and the form of a substance used in the chemical process should be chosen so as to minimize the potential for chemical accidents. So there should not be any exploding reactions that will be taking place, release any gases that pollute the environment, explosions and fires. So it has to be minimized and prevented. It should be prevented. Accidents must be prevented. So this is where like we will be a process can be developed that reduces or minimize the release of gases, some harmful gases, minimize harmful gases, release of harmful gases. So this ultimately will reduce the environmental pollution, and also the awareness to the labor is also very important so that it will reduce the accidents. So in detail we will go like for how the waste can be prevented. So prevention of waste or byproducts is a very important task. Like it is better to prevent waste byproducts than to treat or clean up after it is formed. So in order to achieve this, we have to carry out a synthesis in such a way that the formation of waste or byproducts is minimum or absent. So it is very important. The process should minimize the formation of waste or minimize the formation of byproducts, or should not at least produce that. So that is how we have to design or modify the methods so that we get less hazardous substances into the environment. Cost involved in the treatment and disposal of waste adds to the overall production cost. So the treatment of waste is also adding up cost to the production. So ultimately the product cost will be increasing. The unreacted starting material also forms a part of waste. It means the reactant, whatever is being used, should be 100% used. Otherwise, it is also forming a part of this waste. If discharged, it causes pollution. So this reactant, whenever it is discharged, will cause pollution and requires expenditure for cleaning up. So ultimately cleaning up unnecessary job will be done, like cleaning up the waste will, we need to invest for that cleaning up, which is really not necessary. So including green chemistry in our processes will reduce this process. Next comes the atom economy. So what is this? Synthetic methods should be designed to maximize incorporation of all materials, starting materials and reagents used in the process into a final product. It means most of the starting material, the reactants must be used in the process so that it converts into final product, so that there is no wastage. So chemists globally consider that if the yield of the reaction is above 90%, it is good. The reaction is good. So how is this percentage calculated? Actual yield obtained from reaction, practical reaction that we have done, and the theoretical yield that is expected. Like we are calculating into 100 will give yield percentage. So if it is greater than 90%, the reaction is good. Reaction is good for the manufacturing. So if we see this figure, we can understand that when it is 0% when no reaction or wrong reaction takes place. The atom economy increases with some reactions. So the highest atom efficiency 100% is achieved with addition and rearrangement reactions or isomerization reaction. Why? Because there are no reactants that are being eliminated, so that there is no loss in the atom that is being used. So molecular level there is no loss. Then comes the highest percentage, catalytic reactions. Then is the stoichiometric reagents, the chiral resolution, then finally substitution reaction and elimination reaction. If we see this figure, substitution reaction, elimination reaction has least atom economy because of elimination of byproducts, where it is involving the removal of some atoms into as byproducts. So that is why the atom economy percentage is less. So if you see some examples, for example, here methane is reacting with oxygen to form water and carbon dioxide. So we need water here. Water is a product. So this is the byproduct. So this is the byproduct, carbon dioxide. So if we calculate the atom economy, if we combine these two, it is 80. Total mass is 80 and the product what we have obtained is only 36. So 36, this is a reaction, practical reaction. So 36 by 80, this is a theoretical, what we are giving the reactants into 100, nothing but 45% only. So the atom economy, whenever there is a byproduct formation, the atom economy drops. It means it will be less. The final product produced will be lesser. So that is how there will be waste generation. So in this case, carbon dioxide is the byproduct. So if we see the other example, like it should be 100% yield synthesis. It means perfectly efficient. So whenever the yield is 100%, whenever the atom economy is 100%, the process is efficient, then but it generates significant amounts of waste, then it is not green synthesis. It is not considered as green synthesis. This green synthesis incorporates maximum of starting materials and reagents into final products. So 100% efficiency wherever the process or the reaction is having 100% atom economy is considered as green chemistry, So this is how we calculate and apply the procedures, so that we modify the procedures and be helpful in avoiding pollution. So how is it calculated? It is a method of expressing how efficiently a particular reaction makes use of reactant atoms. We are saying atom economy, it means atoms, how many atoms are really used up in the reaction. So mass of atoms in desired product by mass of atoms in reactants into 100. So this gives a percentage, and this approach does not take yield into account. So yield calculation is not taken into account. However, atom economy is very important to consider before the process is being applied for manufacturing. So the other example is the benzene that can be oxidized to produce malic anhydride, which is an important intermediate chemical. So this is the benzene ring. When reacting with oxygen will give malic anhydride. So these are the byproducts again. Byproduct forming carbon dioxide and water. So what is the atom economy here? If we calculate the atom mass, total mass here, 78 for benzene, 144 for oxygen. 4.5 parts of oxygens we are using. So mass 96 divided by, how is the 96 obtained? Malic anhydride divided by 78 plus 144 into 100. So only 43% atom economy is obtained. Atom economy is obtained. So this is calculated from the relative mass formula masses. So the formula, whatever we are, reactant whatever we are taking, depending on the formula mass, we are calculating the atom economy. So this means that 43% of mass of reactants are used up or ends into final product or the desired product. Here our desired product is only malic anhydride, not the carbon dioxide and water. So the only 43% of our reactant is used in producing the product, the final product. Then we will see the different types of reactions and their atom economy. So how it will vary. Rearrangement reactions. What's happening here? We are only rearranging the atoms. So these reactions involve rearrangement of atoms that make up a molecule. So for example, allyl phenyl ether. Allyl phenyl ether on heating at 200 degrees centigrade gives orthoallyl phenyl. Orthoallyl phenyl. See, if we see this allyl phenyl ether on heating at 200 degrees centigrade, there is some rearrangement happening. So the molecule is getting rearranged. The hydroxyl group is forming here. So there is an attachment, they are forming a bond here. So that is how there is only rearrangement that is happening in this reaction. So no removal of atoms. No removal of atoms. No removal of atoms or byproducts formation. Byproducts formation. Therefore, there is no loss of atoms. So therefore, 100% atom economical. So therefore, this reaction will produce 100% atom economical and is said to be green synthesis. So green chemistry that is involving in synthesis and obtaining 100% atom economical. Next comes the addition reaction. Here we addition of hydrogen to an olefin. So there is an unsaturation here, double bond present in this molecule. Propene with an unsaturation. So we are reacting with hydrogen in the presence of catalyst, nickel catalyst. So the catalyst is also used minimum. So hydrogen is reacting and adding hydrogen to this forming propane. Adding hydrogen to this double bond forming propane. So this is how we are just adding the hydrogen and there is no loss. There is no loss of any of the atoms. So therefore it is 100% atom economical. 100% atom economical. This is how these addition reactions also will be considered for the green synthesis. Next comes the cycloaddition reactions and bromination of olefins. So cycloaddition is adding up the atoms and the reactants forming a cyclomaterial or the molecule. So this is an example like butadiene with two unsaturations, then reacting here, then forming cyclohexene. So this is how it form a cyclic compound, cyclic molecule. Cycloaddition is taking place. Cycloaddition. There is no loss of no byproducts or waste that is forming. Therefore, it is 100% atom economical. One more example is propene with reacting on with bromine. So it is also producing 1,2-dibromopropane. So it is just adding the bromine atoms, bromine to Br2. So it is adding to this molecule, adding molecule. So therefore, adding addition. So no byproducts, no byproducts. Therefore, this is also helpful in producing green products. Therefore, 100% atom economical. 100% atom economical. This is how addition reactions and rearrangement reactions helps in producing the products which involves almost 100% of its reactants ending up into the products. Next comes the substitution reactions. We are substituting an atom. So one atom or a group of atoms is replaced by another atom or group of atoms, and the atom or group that is replaced is not utilized in the final product. Not utilized in the final product. It means it is a forming byproduct. Formation of byproduct. In substitution reaction, formation of byproduct is happening. Byproduct. In this reaction, leaving group C2H5 and one hydrogen atom of amine is not utilized. So, for example, ethyl propionate. So, this is ethyl propionate. So, methyl amine reacting with methyl amine. So, what is it happening? This is reacting with, it is forming N-methyl propionamide. This amide group is coming here, and this ethyl group is leaving. This ethyl group is leaving. This ethyl group is leaving. So, what happens? N-methyl propionamide and ethyl alcohol. Ethyl alcohol is forming. This ethyl alcohol is byproduct. Byproduct. So what happens? There is formation of byproduct and therefore less atom economical than rearrangement. So the ultimate what we are getting, less atom economy from this reaction because of substitution reaction. This group is substituting here and leaving this group so that it is forming a byproduct. So this formation of byproducts will make the atom economy decrease. Then comes the elimination reactions. What happens in the elimination reaction? The name itself indicates elimination takes place. Two or group of atoms are lost from the reactant to form a pi bond. So that is like Huffman elimination reaction. For example, in this example, if we see, there is elimination of water. Water is eliminating. So water is eliminating, and the other product is also forming. That is nothing but the byproduct that is forming upon heating. So what is happening? Least economical. It is only giving 35%. Becoming a least economical, atom economical from all the above reactions or the reactions that we have seen previously. So out of all these, elimination reactions will produce least economy. So these cannot be used for the green synthesis. Next comes the dehydrohalogenation reactions. This is also like, for example, if we take 2-bromo-2-methyl propane, when reacting with sodium ethionate, it forms 2-methyl propane, ethyl alcohol, and sodium bromide. This sodium, in this reaction, this sodium and this bromine will combine. Okay, so it will form ethanol. So this is how the byproducts are forming. So most of the molecule is distorted completely, dissociated completely, and forms major byproducts, and therefore reducing the efficacy. So this is the product forming ultimately 2-methyl propane. For forming a molecule of 2-methyl propane, one molecule of ethanol and sodium bromide is forming. So that is how it will produce less economy, less atom economy. So very less atoms of this product reactant will be used in forming a product. So even less atom economical when compared to Halfman elimination reactions. So it is when compared to elimination reaction, these reactions will produce more byproducts, so that the atom economy drops drastically. So the next one is the less hazardous chemical synthesis. We have seen that atom economy, depending on the reactions, the increase or the decrease of the atom economy happens. So it is always better to consider those reactions that will help in getting more efficiency or the product that is converting the reactants into products. So at the same time, we have to use less hazardous chemicals during our synthesis of any product. So whenever practicable, synthetic methodology should be designed to use and generate substances that possess little or no toxicity to human health and environment. So this is very important. We are advancing in technology and producing many products, but the ultimate waste or the byproducts forming from this procedure should be less toxic to human and environment, that ultimately saves us. So eliminate the hazard, then no need to worry about exposure. So if we eliminate the byproducts, then we need not worry about the exposure once it is in the environment. The chemicals synthesized dyes or paints, for example, should be safe to use. That should be safe to use. Then, for example, thalidomide was used for lessening the effects of nausea and vomiting during pregnancy. So this is a drug that is used for lessening the effects. The effects can be reduced of nausea and vomiting during pregnancy, but the children born to women taking the drug suffered from birth defects. There are some birth defects. So this is a side effect that is coming from that drug. This is the side effects that is happening. So the use of thalidomide was banned ultimately. So this is how every reaction or chemical reaction, synthetic methods has some side effects. So there plays an important role of green chemistry. So there should be some procedures that reduces the use of hazardous substances, so that side effects reduces. So with the advancement of technology, designing and production of safer chemicals has become possible. Just because the technology has improved, the design can be varied in the production, so that the safe chemicals can be used to reduce the side effects. So for example, if we see polycarbonate synthesis using phosgene process. This is a process where polycarbonate is synthesized. So what happens in this? Here there is a formation of polycarbonate. So disadvantages are phosgene is highly toxic and corrosive. This is a corrosive method. So using of this phosgene in process is highly toxic and requires large amounts of COCl2. So it also requires the use of COCl2, which is in the large quantities, and also polycarbonate contaminated with chloride impurities. This also sometimes will contain chloride impurities as such from the reactants. Chloride impurities due to reactants from reactant. So these are the major disadvantages of using hazardous substances. So it is highly toxic. Phosgene is highly toxic in using for using in any processes. So when it comes to a green process of the same method, we will see how it will reduce. So solid state process. So what happens? Say polycarbonate can be synthesized through this method, wherein diphenyl carbonate synthesized without phosgene. So here diphenyl carbonate is synthesized without phosgene usage, and this also eliminates the use of CH2Cl. So this is non-phosgene process. Here we are using diphenyl carbonate. So this is the DPC that is used in forming polycarbonate solvent free. So there are different aspects that are considered, like we are avoiding phosgene and producing polycarbonate. So high quality polycarbonates are obtained. So this is one of the green process. So these are the important that we have to remember, that including the varying the groups can be varied, that chlorine groups are removed, and we are using diphenyl carbonate that is being synthesized, like polycarbonate is synthesized from diphenyl carbonate without the usage of phosgene. So this is how a green procedure is developed to avoid the usage of toxic phosgene. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.